So welcome, this is question number 6 for Edexcel M1 January 2003. So we're given this situation on the board. So it's basically a complaint. I've written on all the bits of information that you get immediately from the first few sentences at the question. Now, I'm not continuing the last little bit of the paragraph just yet, probably because I just want to focus on a few things. Right, so obviously A to B, so that's the length of this green tank, is 3 metres. A to C, so that's the first support point. So you have to know we've got support forces here going up, that we'll call that SC, and the other one SD going the other way, we'll call that ST. Okay, and the distance to SD from A is 0.5 metres. It's got a weight, it's a uniform rod, so that means the weight acts at the centre. Basically it's halfway, so that's the same thing. So it's 1.5 metres and it weighs 120 newtons. Now if that wasn't, and that's in mass, obviously you would have to times that by 9.81 to get the weight of your stuff. Intelligent people will give you that. Unless you're not, then you know, hopefully that helps. A to D is 2 metres, and obviously that's what we're given. Now it says when a particle of weight W is attached to the rod at point E. Now there's no point E in here, so you just have to assume somewhere. Now it doesn't matter if you put it on this side E or this side, but as long as it's in between there, that's all that really matters. I'm just going to put it here. Now it does look different when you do it, but in the end it has the exact same values, so don't worry about having to put it in a specific place. As long as it's between C and D, it should be okay. We'll call this at point E. It says it's got a weight of W. We don't know what this weight is, we'll just call it W. So basically, what that tells us is when that is put there, then it's still in equilibrium, but the support force, to keep it in equilibrium, the support force at C, or the magnitude of the reaction as it calls it, is twice the reaction at D. So therefore the support at C, SC, is 2 times SD. Now that's a crucial thing to helping us understand this question. Because we've got to show that W is equal to 60 over 1 take X. Now the first thing I would do before starting any maths or physics or whatever you want to start doing. Right, we've got these lengths here, but we can add to this without actually being told anymore. We can just, okay, well say, therefore, if the distance between the middle and, so if the distance between the middle and the start is 1.5 metres, the distance between the start and C, 0.5 metres, therefore the distance between C and the middle is the 1.5 metres total distance, take away the distance of C. So that is 1 metre. Okay. Now, obviously, we don't know the distance from the middle to E. However, we do know the distance from the start to E, and we're told that's X metres. Obviously, we're going to have to find it out at some stage. But for now, we're not really bothered about that. So, this bit here, okay, so from E to D. Now, from A to E, from the start to this point E, we know that's X metres. But we know the distance from the start to D is 2 metres. So the distance between, the difference between 2 and X is this distance from the E to D. Just trying to pick different pen time. Right, okay. So if you would, so it's 2 metres take X, that is, so 2 take X metres from E to D. Okay? So that's all the. And now, if you were being really pedantic, you could say, okay, well, from D to B that's 1 metre, really. But we're not really going to be interested in this. It's really more the other one, so you can sort of ignore that if you want. That's really logic. They're the key ones that you need to have on. See, we've added a couple there that it didn't give us, and that is going to be key to helping us work out this question. Right. So, what you need to think is, okay, what position do you want to start from? Now, we're going to end up doing from both positions because we don't know support force C and we don't know support force D. I'm going to start from wherever I did in my answers. which is, I'm going to start at support D. Okay, so at support D, if we want to start support C, then we have to, so it's times the distance between them, because this C has got a reaction force and it's going this way. So when you're at D, you think C is pulling you clockwise, E is pulling you clockwise, and the weight is pulling you clockwise. Okay? So, let's work this out. So it's times 1.5 metres, which is the distance between them, equals, so pull out in brackets. Now, the way I think of it, it's quite a cheating way really, but it works for all of these kind of questions, which is what you're going to get in them one. So, the way I think of it is, so you've got a support force, you times it by the distance between them, between the two support forces, because you want you to have one, or unless probably it would be in the centre, but you wouldn't need to work anything out then. Anyway, so you do times the distance between them, and then you look at each single one that's in between them, because anything outside of here is not going to make much of a difference. Well, you generally won't have something outside of there, but it doesn't make a difference. So what you do is say if you're doing from SD, you mean times the distance between them, and then you do them all to the other support force in terms of you do the weight and then the distance to the other support force. So E, right. Okay, so hopefully that made some kind of sense. So we are at SD, so it's, to the other one it's 120 newtons times 1 metre. So it's equal to 120 newtons times 1. Now, obviously, you know that's 120 newton metres. And then, oh, that's bad, isn't it? Okay, so that is plus W, because this is this unknown weight here, W, times X now, we don't know the distance to C straight off, but we know the distance to the start is X, and the distance to C from X is 0.5. From the start is 0.5, so it's W times X take 0.5 metres. Okay, and we'll call that equation 1. Now, you could simplify that and say that's 120 newton metres, which would be brilliant, but there's no point. So we do a similar thing for SC. So SC times the distance between them, times 1.5 metres, and then what you do is then the reverse of that, and you do them all to the other support force. So you still do the weight, 120 newtons. However, we don't know, obviously, because the distance between them is 1.5 metres, sorry, should put that on, it's another distance. Because it's just 2 metres, take 0.5, which gets you 1.5 metres. Okay, so if we want to do it to the other support force, so we're at SC and we want to look at them to SD, so it's 120 newtons to SD, so it's 1 metre from C to the middle, so therefore it must be 0.5 from the middle to SD. So it's times 0.5 metres. Plus, now, still W, times, so this W is not the weight of the plank, it's the weight of this E that we don't know. So whatever weight that is, times the distance to SD, which is 2 take X metres. Okay, call that equation 2. Now, what we're told, so that's as much as we can do. Now, you could simplify that equation there, but it's not going to help you. Well, it will, but... So, when I mean simplifies, you change that to 60 newtons, which we're going to do anyway, actually. Yeah, so if you change that now to 60 newtons, we could rewrite it out again. So 60 newtons, and then Newton meters, sorry. And the top one there is going to be 120 Newton meters. So I'll move out of the way in a minute. Okay, so there are your two equations simplified, that's what you should have. Now we're told SC is 2 times SD. So SC times 1.5 is equal to 60 Newton meters plus W times 2x, 2 times x meters. So if SC is equal to 2 times SD, so we'll rewrite this equation out. However, we don't need to write out SC times 1.5 equals all this. As this is equal to SC times 1.5, and this is SD times 1.5, then they're multiplied by the same proportion. So we don't need to divide both sides by 1.5, because all we'll end up doing is getting ourselves in a tricky mess. So what I'm going to do instead is just assume SC has been increased by the same amount SC has, which in proportion it has. So if they're increased by the same proportions, we don't need to worry about dividing them by 1.5. So you could just do 60 Newton meters plus W times 2 take X, which I'm just writing out equation 1. So if I put this in a number 1 form, so number 2 is equal to 2 times number 1, which actually makes sense, but I'm talking in terms of equations here. 2 take X meters, and that's equal to 2 times, now I'll put this in square brackets, 120 Newton meters plus W times X take 0.5 meters. Okay? Right. So therefore, you'd leave this as it is, and then you would expand this. Now, as I'm running out of room, I'm just going to rub each term off and simplify it. Okay, so hopefully you can see that. So it says 60 Newton meters plus W times 2 take X meters is equal to 2 times the whole of 120 Newton meters plus W take X take 0.5 meters. Sorry, just any message here? Obviously not that popular. Right, so the first thing you would do is expand this, because 2 times that plus 2 times that is going to be the same as 2 times all of that. Logic. So the first thing you do is 2 times 120 Newton meters, which is 240 Newton meters. Okay, and that is plus 2 times W take X take 0.5 meters. Okay, so you just simply expand that as you would do any other, say if that was just a normal expansion in terms of 2 times X plus B. So it's 2 times W times X take 0.5 meters. So you just it's W times X take 5. So really, one sec, I'll write this out a bit more, because I was getting myself confused because I hadn't written it properly. So it's 2 times W times X take 0.5 meters. So it's like a double bracket there. Okay. So we do 2 times W and then we times that by X. So we do 2 times W times and then 2 W. Right, it's like this. 2W times X take 0.5. So it's 2W times X and then 2W times 0.5 meters. Okay? Hopefully that makes some kind of sense. So when we expand this, I'm just going to focus on expanding this bit. So you could keep writing like this bit again, and this bit again, and this bit again, but I'm going to do it as a continual change thing on here. So the next step you would do after writing that is expand this bit. So 2 times W, 2W times X would be 2WX. And that's meters, remember? And then 2W times 0.5 meters would just be take W meters. Okay, so then what you do now is expand this bit. So it's 2W times 2 take X meters, so you'd expand that, so it would be W times 2, 2W take 2 W times X. Okay, so 2 times W meters would be 2W meters. 2W times negative X meters would be take 2W X meters. Sorry, W times negative X meters. Sorry about this. It would be W X meters. Right. So then what we do is, so if I'm going to simplify that now, so if I take 60 from both sides, so take away 60 from this side, take away 60 from this side, we're going to be left with 180 Newton meters. Okay, and then if we move both of these over to the other side, so what I'm going to do is take W meters, add W meters both sides, so 3 W meters, and then add take away 2 WX meters from both sides, so that'd take 3 WX meters on the left hand side, rub that off, and that's equal to 180 Newton meters. Now bearing in mind it wants it in the form W equals 60 over 1 take X meters. Now what we want is W on its own, W equals something. Now we've got a common factor of W here, so what we're going to do is take out W as a common factor. So that's 3, because we just ignore the meters really. Take 3x. Oh, actually no, sorry. Because they both you could have done that, but it would have been pointless because they both contain 3. All of them are a factor of 3, so you could divide it all by 3. Let's get rid of these 3's. So that's just W meters take WX meters equals 60 meters. 60 Newton meters. Or you could divide it all by 3 meters. So we get rid of meters. Right. Factorise that, so that's W brackets 1 take X is equal to 60 newtons. Divide both sides by 1 take X, therefore W equals 60 newtons, or 60 over 1 take X, and that is what is required. Okay, so sorry about that. So basically what we did, if you didn't quite get how I laid it out there, because I kind of tried to just keep it on one board, and I think I probably should have made this a bit smaller. But what we did was we said, okay, well SC is 2 times SD, so we ignored these 2 bits because SC and SD are both times by 1.5, so you can kind of ignore rearranging these. And then because SC is 2 times SD, this was equal to 2 times equation 1, as it says up here. And when we simplified it down, just expanded it like normal. So the 2 times W times 2 take X, it'd be 2W times 2 take X, so you expand that as normal. And then we divide it all by 3, because you could get 3 into all of them, because they can remain the same. Factorise the left hand side, because they both had a common factor of W, and we wanted W on its own. Divide both sides by 1 take X, a factor, and then that got us to the end answer that it wanted. So that's all question 7. Not question 7. That's with a little bit more on question 6. But it just says, hence deduce all the possible range of values, for X. So what we're trying to find out is this, basically we've got this distance here from A to E, and they just denote it by X meters. So we've got to use that equation that we did in part A to be able to work out the possible values, range of values for X. Hello, this is the rest of question 6 for Edexcel, that one we were just doing before. I need to go on about it. Anyway, so sorry it's a bit like this, but I did do question B as the proper thing, but I ended up messing it up. Just because the answer on this scheme I was looking at was completely incorrect. Not the official mark scheme, just something someone else had done. Anyway, so I was just backing into my answers and I thought they were right, and obviously they're not. Now this weight here, part B is just logic really, because we've got a weight, and now obviously the weight cannot be negative, so therefore 1 take X could not be greater than 1, because if it was, it'd be 60 over -2 or whatever it might be, and then you get a weight of -30, and obviously you can't have that because you can't take away weight, but it could be any number just as long as it's below, as long as it's below 1. So as you can see on the mark scheme, that's exactly what it says. I don't normally focus on my computer because camera normally doesn't get it, but so hopefully you got the idea. Them numbers there are just for me, just putting it on my computer. So anyway, hopefully that made sense. Sorry about adding this little bit in this way, but I tried to keep it nice and short. So I'll end it there. Thanks for watching, and we'll see you in question 7.